This is the screencast for section 5.3, example 2. We're going to find bounds for an integral. But first we need to go back to those last two rules on our properties page that we didn't talk about. Now for number 6, the max and min equality, a picture will definitely speak 1,000 words here. The words are very messy, but what this is saying is if the maximum of f and the minimum of f are the maximum y value and minimum y values, then here's what happens. The minimum of f, so the minimum value, let's call that on this little picture here, this guy, the minimum value, times b minus a. So we're looking at a distance equals rate times time situation. So this rectangle has to be less than or equal to the actual area under the curve, which makes sense. If that's the minimum value, it's kind of like an underestimate with one big rectangle. Now, the opposite would happen because then the maximum here would be this y value, and if we use it as our height of our one big rectangle, that is an overestimate, so the actual integral has to be less than or equal to the actual estimate with the one big rectangle, our maximum y value times b minus a. This is our overestimate. Now this concept, number 7, may seem just a little bit logical to you, but if the function f of x is always greater than g of x, so always higher, the y values are always bigger, that means the area under the curve of f of x is always bigger than the area under the curve of g of x. So if you have, here's f of x, here's g of x, isn't the area under this curve going to be a lot bigger than just the area under this curve? Well, definitely. Then the second part to that, if f of x is greater than or equal to 0, so if we have greater than or equal to 0 for f of x, the antiderivative from a to b of f of x dx, which is greater than 0, the actual integral has to be positive then. Well, nothing dipped below the x-axis, so it has to be positive. So now back to example 2. The top here says the max-min inequality for definite integrals, or rule number 6, says that the minimum of f times b minus a is a lower bound and vice versa for an upper bound. Okay, so we're going to use that now. Finding bounds for an integral. Show that the value of the antiderivative from 0 to 1 of the square root of 1 plus cosine of x dx is less than 3/2. Okay, so we need to show that it's less than 3/2. I'm going to say find its upper bound, and then if its upper bound is less than 3/2, then we know the integral has to be less than 3/2. So first of all, let's look at the maximum of f times b minus a. Well, the maximum of f is square root of 1 plus cosine of x. The highest value the square root of 1 plus cosine of x is going to get to is when cosine is at its smallest, or is at its largest value. So that would be the cosine of, well, it doesn't even matter because it has to be, cosine fluctuates between -1 and 1, so we want cosine to be 1. So the maximum of f is going to be square root of 1 plus 1. Now b minus a then is 1 minus 0. So that whole deal is square root 2. So I know the square root 2, I don't know, is about 1.4 something, a little less than 3/2. So if square root 2 is the highest value the integral can take, the upper bound, that means, and that's only 1.4, it definitely has to be less than 1.5, less than 3/2. So let's say first that the integral from 0 to 1 of the square root of 1 plus cosine of x dx is bounded above by square root 2. Then, since the square root 2 is less than 3/2, the integral from 0 to 1 of square root of 1 plus cosine of x dx has to be less than 3/2. The highest value can be is 1.4. Definitely has to be less than 1.5 then. Then now try problem number 7. Says show that the value of the integral from 0 to 1 of sine of x squared dx cannot possibly be 2. Oh. Alright, so cannot possibly be 2. It's a little bit vague as to whether, say, 2 is too high for this or 2 is too low for this. So let's find both the upper and lower bounds. And maybe you're like, oh, Miss Larson, I know what I need to do. Fine, but let's just try it. Let's find both the upper bound and the lower bound for each of these. So let's see. Upper bound is going to be the max of f times b minus a. The lower bound is going to be the min of f times b minus a. Alright, the max of f, the maximum that the sign of anything can be is 1. So that'd be 1 times and then 1 minus 0. So our upper bound is 1. Our lower bound, the minimum of f, is, well, the smallest sign can be is negative 1. Even though we're squaring x, we can still get out something that is negative 1. And then b minus a is 1 minus 0, so that's negative 1. Regardless of what our lower bound is, we can see that since the integral from 0 to 1 of sine of x squared dx is bounded above by 1, it cannot possibly be 2.